In this video lesson, we'll learn more about the slopes of linear functions. So as we learned before, any linear function has the form y equals to some number times x plus another number. Or in other words, y equals mx plus b, where m and b are some constants. Now, as we discovered in the last video, m, the constant multiplied times x, is the slope. However, this doesn't really help us understand what slope looks like or what it means graphically. So we'll draw a bunch of examples. First, we will start with y equals x. Now, it might not seem like there's any slope at all because we're not multiplying x by anything. But really, we are multiplying x by 1. The slope is 1. So let's make a graph of this function. To do that, first we will make a table of values for x and y. We will take x equals 0, 1, 2, and 3. Of course, y just equals x, so we can copy the values of x into the column for y. I will now draw the coordinate plane. Now we are ready to draw the line. We first take the point 0, 0, and we draw it. It's just the origin. And then we'll take the next point, 1, 1, and draw it. Now that is enough to be able to graph our line, but just to be sure, we'll take a third point, 2, 2. Now we'll connect these points with a ruler because they all lie on the same line. And this will be our first line that we will draw. After that, we're going to draw some more lines on top to compare their slopes. So here's our line. We need to label it and put the arrows on. Now we see that y changes by 1 every time x changes by 1. That is, when x increases by 1, y also increases by 1. That is what we mean by slope. Per unit change in x, y changes by 1. So the slope is indeed 1. We are ready to move on to our next example function, y equals 2x. Since the x is multiplied by 2, the slope of this function must be 2. We will take x equals to 0, 1, 2, 3 as before. If x equals 0, then 2 times 0 is just 0, so y equals 0. If x equals 1, 2 times 1 is 2. X equals 2, 2 times 2 is 4. And if x equals to 3, then 2 times 3 is 6. So here we have our table. Now we notice again that every time x changes by 1, y changes by 2. So per unit change in x, y changes by 2, confirming that the slope is 2. We're ready to graph this line. 0, 0 is already labeled and drawn. It's the origin, and 1, 2 is 1 to the right and 2 up from the origin. So there it's drawn. We connect the points with our ruler. And there we have the line. Time to draw arrows and label. So let's take another example function now. We will move on to y equals to 3x. Now since we have x multiplied by 3, the slope should be 3. Of course, if x equals 0, then y also equals 0. 3 times 1 is 3, giving y equals 3 if x equals 1. 3 times 2 is 6. And 3 times 3 is 9. And again, we notice that y increases by 3 every time x increases by 1. This confirms that the slope is 3 as indicated in the function. Now we will graph this by plotting 2 points and connecting them with a ruler. 0, 0, a point that all of these lines have in common, has already been drawn. 1, 3 is 1 to the right and 3 up from the origin. Now we can just make the line. And put on some arrows and label it. Looks like I'll have to make some room for the label and cut off the end of that line. Now what we're going to do, we'll first notice we're going to label all these lines with their slope. So we have slope 1, and then 2 and 3. And now we're going to move on to functions with negative slope, starting with y equals to negative x. Of course, if x equals 0, then y also equals 0, and the rest of the table is really easy to fill out just by putting a negative sign on. 0, 0 has already been drawn, and 1, negative 1 has now also been added, 1 to the right and 1 below the origin. We've connected these 2 points, and we've labeled this function. It has slope negative 1 because y equals negative x is the same as negative 1 times x. Now we will look at the function y equals negative 2x. Of course, 0, 0 is a point for this line, and then after that, we just multiply by negative 2. Zero, 0, as before, is drawn, and 1, negative 2 is 1 to the right and 2 below the origin. After this line, we will draw the line y equals negative 3x, and we will be able to draw a conclusion about what slope really means in the context of the graph. And here I've labeled the negative 2 is the slope of the function. So now y equals negative 3x. Negative 3 times 0 is 0. Negative 3 times 1 is negative 3. Negative 3 times 2 is negative 6. And negative 3 times 3 is negative 9. So we only need 2 points to make our graph as before. And notice again that every time x increases by 1, y decreases by 3, which is hinted by the negative 3 multiplied by the x, which we know is the slope. So now we are ready to draw our 2 points, 0, 0 is the origin, and 1, negative 3 is 1 to the right, and 3 below from the origin. Now we can see that for positive slope, the larger the slope, the closer the line is to being vertical. And for negative slope, the smaller the slope, the closer it is to being vertical as well. So in general, the closer the slope is to 0, the closer the line is to being horizontal. And the further away from 0 the slope is, the closer the line is to being vertical. I'm just circling all the slopes of these functions and connecting them to the line so that you can better see the connection between the number of the slope and the way the line looks. Also notice that for negative slope, the lines go down. And for positive, they go up. So now we will clean up and we will move on to the two most confusing examples of slopes of functions. It's actually the slopes of the vertical line and the horizontal line. But we'll get there in time. We'll start with the function y equals 1. So as usual, let's make a table of values of x and the corresponding y values. I'll just take x equals 0, 1, 2, and 3 as usual. But notice, this function does not have an x in it. Y is a 1 no matter what. So we can just fill in y equals 1. Now let's draw these points. 0, 1 is just 1 above the origin. 1, 1 is 1 to the right and 1 above the origin. And then 2, 1 will be 2 to the right and 1 above. And 3, 1 will be 3 to the right and 1 above. So here I have drawn these points, and all of them are just 1 above the x-axis. We connect them with a ruler, and here's our straight line. Notice it is horizontal. So what does this mean about the slope of this function? Well, we're about to answer that question. Y equals 1 can also be written as y equals 0 times x plus 1. That is because 0 times any number, whatever x may be, is still 0. And 0 plus 1 will still be 1. So we have 0 times x, so the slope must be 0. So that answers the question about the horizontal line. What you should always remember is that if y is equal to a constant, for example 1 or 2 or 1.5, that also means that the slope of this line will be 0. So now we will go on to the next example, which will be the vertical line. First, a little bit of cleanup. So this line will have the function x equals 1. Gotta fix our coordinate axis here. So x equals 1. Now we can't really make a table for this because earlier we were just changing x and getting different values of y. But now there's no y in the picture, it's just x equals 1. X equals 1 is any point that is 1 to the right of the y-axis. So for example, these points I'm drawing are all have the x-coordinate 1. So the straight line will just be this vertical line. Now what could the slope of this function possibly mean? Well, really, what we're dealing with isn't technically a function. because there's no y. For it to be a function, we have to have y equaling to something. So really, what is the slope equal to? Well, since it's not a function, we usually call the slope undefined. There is no number that the slope is equal to. It simply does not exist. And again, for this to be a linear function, it has to have the form y equals mx plus b. And the y has to be there. We do have a line when we draw it, but it's not a function because there's no y. And to remember that there is no slope, no y means no slope. It's just undefined. And that is the end of this lecture. Thank you for watching.